Well, welcome back. Thank you for joining me today as we begin discussing mole calculations. So we talked in the last video about what moles are and that they're this quantity of substance used a lot in science class, this big number 6.02 times 10 to the 23rd. Today, we're going to use what we learned in the last video, and we're going to determine the mass of a substance given the number of moles. We're going to talk about the number of moles given a mass, and then we're going to calculate atoms both ways as well. So that's where we're going. So let's get started. So first off, a mole, which we talked in the last video, is Avogadro's number of particles. That mole is 6.02 times 10 to the 23rd particles. And 1 mole of substance is equal to its molar mass, or atomic mass, in grams of a substance. And so today, we're going to look at calculations. And to do that, I'm going to have you draw what I call Mole Mountain. So Mole Mountain is kind of the way that I use these different terms, and so it's going to look like so. Maybe. Shoot, pen's not alive. Mole Mountain's going to look like this. Sorry, my pen's malfunctioning, but we're going to try it. Mole Mountain looks like this. So if you have moles on top of Mole Mountain, you can go to either the mass of substance or you can go to particles of substance. Okay, and then on Mole Mountain there are up and down chutes. And so my down chutes are on the bottom side, my up chutes are on the top side here. And I think of it, you could slide down Mole Mountain. If you were to get on this, you would slide to the bottom both ways. If you wanted to go to the top, you could use monkey bars. It'd be kind of painful. Or you could get on top of monkey bars and crawl across the top. But the monkey bars go up top, the slide goes on the bottom. To go from mass to moles, again, we have to use, we learned in the last video, this thing called molar mass. And so we're going to use molar mass to go from moles to mass or mass to moles. On this side, we're going to use Avogadro's number, which as a reminder is 6.02 times 10 to the 23rd particles. Now I do factor labeling, I do unit conversions. I do it this way where I use like a train track method. And so if this line here is this arrow going one way or the other, if I'm going down, that means that my molar mass goes on top, so I'm going to multiply by molar mass. If I'm going up, this is my division bar, and my molar mass is on bottom. So I would have something that looks like this, where molar mass goes here. And so that's why I draw it the way I do. Same thing, Avogadro's number. The first one, you have, it's going up, and so we have, if we're going down, it's on top, so it's 6.02 times 10 to the 23rd, and that's going to be particles per 1 mole. And again, if we're going the other way, if we're going from particles to moles, we're going to divide, so it's going to be the opposite. But this is my visual representation showing you what that's going to look like. Okay? So for example, if you have 0.550 moles of sodium, and I want to know how many atoms we have. So we're going to write down, we start with 0.550. And that's moles, you can abbreviate MOL, of Na. Pen is kind of malfunctioning, I apologize. So I have 0.550 moles of sodium. I'm trying to go from moles to atoms. So again, reminder, my moles, my grams, and my particles. Remember, atoms are one of those particles we can have. So if I'm going from moles to particles, I have to put my 6.02 on top. So that's going to be 6.02 times 10 to the 23rd. It's going to be particles. In this case, it's going to be atoms of sodium. On the bottom is going to be 1 mole of sodium. and you see that 1 mole of sodium here and 1 mole of sodium here can cancel. So those disappear, and you calculate, and you get this 0.550 times 6.02 times 10 to the 23rd should give you the answer that's shown up here is 3.31 times 10 to the 23rd. So E means times 10 if I hadn't said that, if you weren't familiar with that. And unit's going to be atoms of
Scott
Na.
Suits, you have a call on 6531. Scott Suits.
Next example. If we have 2.38 times 10 to the 23 molecules, how many moles of water do I have? So in this case, I'm giving you the answer again. So 0.395 is what we should come to. To get there, we're going to start with 2.38 times 10, capital E, to the 20, to the 23rd molecules of water. I'm going from molecules into moles, so I'm climbing on top this time of those monkey bars. So remember, this one goes on bottom. So this is my Avogadro's number here is 6.02 times 10 to the 23rd molecules H2O for 1 mole of H2O. And when I calculate that out, I should get 0.395. Something that's really important that I'm going to emphasize a lot is I would put this number in parentheses, but more importantly, I would put this number in parentheses. If you don't, sometimes your calculator will take 2.38 times 10 to the 23rd, divide it by 6.02, and take that whole answer times 10 to the 23rd, which is going to give you a very large number. So if you're calculating moles, you should have something relatively reasonable for numbers. Should never have a times 10 with it when we're talking moles, unless somebody's being ridiculous on the question. Okay, so moles should always be a normal number that you can work with. Now, what if we go from grams? Go to grams. So we have 0.561 moles of magnesium. I'm going to grams. So remember back on Mole Mountain, we have moles and grams, masses on this side. So if we're going down, the thing on top here was molar mass. And so we got to multiply by the molar mass of magnesium. If we look at the periodic table, mine says 24.305. It's going to be grams of Mg divided by 1 mole of Mg. Multiply these two out, you should get 13.6 grams of magnesium. Okay, and the last one, if I have 45.3 grams of sodium sulfate, how many moles of sodium sulfate do I have? And so I'm starting with 45.3 grams of sodium sulfate, Na2SO4. Okay, now I have to find my molar mass of sodium sulfate. So I'm going to take 22.99 times 2 plus sulfur, which is 32.065, plus SO4, 4 times 16 or 64, however you want to word it. You multiply all those together. If you take 22.99 times 2 plus the 32.065 plus 64, you should get 142.0, I'm going to go 0.05. So we should have 142, 142.05. And that's grams per mole. Okay, so grams is on top right now, so I need to put my 142.05 grams of Na2SO4 on top bottom. 1 mole goes on top. And if I divide 45.3 by my answer, I should get 0.319. And this is moles because my grams cancel here and here. Moles of Na2SO4. Okay, these are mole conversions and things I'm going to expect you to be able to do in this course. Okay, so here's some review stuff. A mole is Avogadro's number of particles, so remind yourself, what is that number? A mole of substance has a mass equal to its atomic mass in grams. So what about a compound? How would I find a compound? And then last but not least, I want you to try to calculate how many molecules are in 350.0 grams of iron 3 oxide. Okay, I'll try to help a little bit with this quick. So we have mole mountain. We have moles. On this side is mass, and on this side is particles. Okay, I'm asking you how many molecules are in 350 grams. So I'm starting here at mass. Okay, we're starting at mass. Oops. And we're trying to get all the way over here to particles. That's where I want to end up. So I'm starting at mass, I'm ending at particles. I have to be careful. You have to go up to moles, and then you have to go down to particles. We can't jump this way. This is called the mole hole. We don't want to be in the mole hole. Oops, I don't need the S. Not moles hole, the mole hole. So stay out of the mole hole, and good luck on this question. Thank you for joining me today, and I will see you again next time.